Hello, my name is Andrew Satia, and I wanted to talk to you guys today about my revisions, proposed revisions for a modern dimmer light switch. Now, what a modern dimmer light switch is, it's a small circular device that is used to control the dimming settings on your light source, whether it be a bulb or a giant chandelier hanging from your ceiling. What happens is that when you turn the knob counterclockwise, you create a dimming effect. And when you turn it clockwise, it brightens up the room. And this device's purpose is to allow the user control over the amount of light settings that he wants in his room. And also it has potential to reduce costs by allowing how much energy is being used at the same time. Now, how does a dimmer work? Well, the dimmer is composed of three main parts: a semiconductor, a firing capacitor, and a variable resistor. The semiconductor, known as a triac, chops up the AC current because of its fluctuating reversal pattern. Basically, what an AC current does is that it sends energy one way and then it directs it the other way continuously. So it's always going back and forth. Because of this, it creates a sine wave pattern, and at peak intervals, the triac acts as a closed switch, so that whenever energy is flowing at its peak moment, enough energy is being supplied throughout the triac to go through the entire system. But whenever the current approaches zero, the triac will act as an open switch. And in that case, what happens is that a fire capacitor will absorb energy whenever the switch is closed, so that whenever the switch is open, it can fire this energy into the triac to ensure that it has enough energy to supply the circuit. Now, the most important component is the variable resistor. And what the variable resistor is a circular resistive material with a control arm in the middle that moves across it by degrees. So it moves in 180 degrees left and right. And what it does is that, hold on. Yeah, this is the AC current. You can see the peak voltage, and whenever it hits down to zero is when it acts as an open switch, and it continues as a closed switch here and there. Here is a picture of the circuit, and here is the variable resistor, the triac, and the firing capacitor. So the variable resistor you see here, it's a circular material. It's a circular resistive material. So what happens is that whenever you turn the knob to a clockwise position, let's say you're turning it down here, the current will have to go through less of the resistive material before being reconnected with the circuit. So as opposed to when the knob is turned counterclockwise, say for example it's over here, the energy will have to go through much more of the resistive material before being connected. Of course, the control arm is what is connected to the knob on the dimmer switch. So whenever you turn the dimmer switch, you're actually turning the control arm on the variable resistor. My proposed redesign will completely change the appearance and function of how the dimmer switch looks and works. Appearance-wise, the new design will be encased in a hard plastic casing with a display screen on the front and an internal microphone, a very small quarter-size internal microphone that'll be behind a grill surrounded by a mesh filter. Now, one of the reasons why I want to do this redesign is because modern dimmer switches are can only function through physical contact. You can only turn the knob, by physically doing it with your hands. Well, I wanted to be able to do it so that instead of physically getting up there and having to turn it, you would instead give a simple voice command, and the light settings will change to your command. So the light command will be, even though the microphone will be picking up audio from all over the room, only one simple voice command is going to be activating the entire function, and that voice command is lights X%, where X is any number from 0 through 100. So for example, I say lights 50%. The microphone will pick that up and go through all its steps so that the output, you see your lights change to exactly 50%. And you can go through 21%, 70%, and you will start seeing your light dim and then go back up to a very bright high setting. Another unique function of mine is to have a cost calculating program that will display on the screen your in real time your monthly cost of usage while your dimmer is being operated. So, for example, say you leave your dimmer switch on for 2 hours, and you notice that it's ran you $3. Well, that $3 is going to tag on there, and say, well, maybe I want to turn off my dimmer so I can reduce some money. So you turn off your dimmer switch, and that $3 is still there. It's going to show that your dimmer has used $3. Say that you leave it off for 2-3 days, and the next day you have a party at your house, and you leave it on the whole day. Well, you see the next morning that that by leaving it on the whole day, it's cost you $10. So you see that it's going to be $13 at that standpoint. That's what this cost calculator is going to do. It's going to calculate the cost in real time of the usage per hour while it's happening, and it keeps a tally of it for that monthly period, so that whenever the next month rolls over, the price is reset, or the cost